This is a pulse oximeter machine made with Arduino. It's a simple summer project, and today I'm going to show you what this machine does, how it works, and a step-by-step guide on how we can build it as well. Also, if you want to see more videos like this, hit that subscribe button. It would help out a lot. So, how does this device actually work? Its main goal is to measure your heart rate and the percentage of the oxygen in your blood, SpO2, using two light sources, red, which you can see, and the infrared, which you can't. It shines both through your finger, and a photodiode on the other side measures how much each gets through. Oxygenated and deoxygenated blood absorb these two wavelengths differently, so the ratio between them tells you how much your blood is carrying oxygen. And because your arteries pulse with every heartbeat, the pulsing part of the signal comes purely from arterial blood, which is what makes us work without a needle. Today, we're going to use a Max 3100 chip, which has an entire optical front end built into it. The problem is, it runs on 3.3 voltage, while the Arduino's I2C is 5 volts. So, we have to come up with a little solution. Let's get into that and to the build. For the build, the things that we require are a breadboard, jumper wires, an Arduino, a Max 3100 chip, and two 1 kilo ohm resistors. Start by connecting the grounds. Take one jumper from the ground pin and connect that to the Arduino's grounds. Okay, here's the tricky part. Get one jumper, connect that to the 3.3 voltage in the Arduino, then connect the other head to the breadboard. Now from that exact same row, place 3 more jumper heads. First one is going directly to the voltage inputs, and the other 2 jumpers are going to the legs of the two 1 kilo ohm resistors. After doing that, connect the other legs of these resistors to SDA and SCL using another jumper. Finally, get a jumper wire from SDA to A4 and SCL to A5. We're not going to be using the rest of the pins, and our circuit is complete. Now open Arduino IDE and paste the code in the description. I will share my GitHub repository and you can view it and copy it there. Make sure your baud rate is set to 115,200, otherwise it will not work. Verify your code and then upload it to your Arduino, and you can close the software. I will place every single library required in the description, so you can check it out. After closing Arduino IDE, open Python. I use VS Code, but yours could be PyCharm as well. Paste the code from the GitHub repository and you're done. Here is the 4 things that the code does. It reads the sensor without freezing the display. Then it filters the signal at 0.5 to 5 Hz Butterworth bandpass. It auto-scales the waveform, and it behaves like a hospital monitor. Here are the 2 codes you can use to run your command. After that, place your finger on top of the chip and you're done. Make sure it's not a bright environment because photodiodes might have a little hard time sensing your finger. Thank you so much for watching. If you enjoyed it and if you want to see more projects like this, hit that subscribe button and I'll see you in the next video.